Okay, welcome back everyone to another week of Unity workshop. So this is our second week in software engineering and games. So today we'll be covering more on the software engineering aspect for specifically for Unity and for the C# programming language. So before we start, please scan this QR code for attendance. Okay. And let's get started with a very basic detail on C#. This is the fundamental when it comes to what we want to handle, what we want to be doing next up. So this is what we call namespaces. So a namespace in C# is a way for you to organize different types together. And it's also very common in other languages that support object-oriented programming. So for example, you have packages in Java. You also have namespaces in C++, it's the same name. And you also have modules in Python and JavaScript. So these are ways that you can group types that potentially have a similar functionality or a similar set of features together, and C# call them namespaces. Unlike Java packages though, so if you have taken 2030 or 2030S, or if you're taking right now, you should know what are Java packages. Unlike Java packages, C# namespaces are actually just logical grouping, and it does not enforce any kind of directory structure. So when you use Java packages, you probably need to create folders that resemble the same hierarchy as you do for the package. For example, if you create a CS2030S package, then it must be in the CS2030S folder under your main Java directory. But C# doesn't enforce this. In fact, you can put your namespaces in any folder, and you can give it a different namespace name and a different namespace path as you desire, and it will not impact the functionality of this code. So it's just logical grouping, and it does not really resemble the directory rule. Secondly, when you use a namespace, you use a namespace by using the using keyword. If you looked up in any of your C# code that you have done for Unity, you'll see that there is always this using Unity engine. So this using keyword shows that we're actually referring to a namespace. So this Unity engine is a namespace. So we are using the Unity engine namespace, and implicitly by default, when you use a namespace, you always have access to all the types that is within the same namespace. Okay, and thirdly, there is actually no such thing as a package protected modifier, like in Java. Java's default modifier is package protected, but there's no such thing in C#. But I do like C#'s access modifiers a little bit more. And you can define more than one public class in a single file in C#. So it is possible to define several classes that are potentially just helper classes for a particular functionality in the same file, and you can still make them public. So you don't need to, unlike Java enforces one public class per file, and other classes that you write in the same file must either be package protected or private. So you can look more about the namespaces thing from Microsoft's documentation website. This is again just pure C# things. Okay. So let's get started with working on this namespace thing. So I'm just going to very quickly demo how you can try to use namespace in your project. So remember that we have all of our enemy code that we have refactored in last week's workshop, which I also already pushed to GitHub so you can take a look at it. So we probably want to group all of our enemy within the same namespace, because obviously this is a feature with all of its components being related to each other. Generally speaking, you want to group classes in one of two ways. One is you group them with the same functionality. For example, code that handles movement will be inside the same namespace. But as your project gets bigger, this might be very difficult for you to track which class is which class. So if you have more than just player and enemy that can move, you have animals, you have different types of monsters and everything that can move, then you might encounter a problem where you have very many different movement scripts for different kind of entities in the game, and then it makes it very difficult for you to track. So generally speaking, when it comes to working on large projects, the better way to organize your namespaces is by feature. So for every feature that you implement, you put all of those code inside the same namespace. So it makes it easier for you to refer to and to figure out which which namespace you should refer to when you're trying to access a single feature. So it's very easy to actually introduce a new namespace. So for example, for this enemy controller class, all I need to do is to, at the very top, before I put in the public class, I type in namespace, and I'll be able to just directly type a namespace in. So let's just call this gameplay.enemy so that we know that this is a class that is inside the gameplay enemy namespace. And as I put all of them in, you'll see that this enemy controller class is already in my namespace. So likewise, if I try to go into my different classes, for example, when I go into like my idle state, you see that now there's this red squiggly line for an enemy controller, because I no longer use this namespace. So if I want to fix this, I can do using gameplay.enemy, which is going to refer this back. But obviously we also want to group all of this inside of the same namespace. So all I'm going to do is to make sure that all of this is inside the same namespace. Oh, sorry, not using. So it should be namespace, gameplay enemy, and we're gonna put all of these classes inside of the same namespace. Okay. Movement controller, idle, state controller. Okay. So you just put all of these inside namespaces, and you should be able to see that it solves all your problems. And the enemy state controller. Enemy aggro. Enemy aggro should also be in the namespace. I think that should be all the classes inside of this namespace that I need to add. Yeah, so the other code, I don't think I need to touch them. The iState, probably we don't, let's just put this in just for consistency's sake. So as you can see, even though I don't have this folder called gameplay, I am still able to declare a namespace to it, because C# namespacing is logical, is purely logical, and it does not enforce any directory rules. And now you have successfully grouped everything into the namespace called gameplay.enemy. So if your class, if other kind of code needs to refer to it, make sure that at the very top you include the using statement gameplay.enemy, and this will allow you to access all the public classes inside of this namespace. Okay, cool. Are we good with namespacing? So it's pretty simple, but it's also a very powerful way for you to make your code base organized. So what comes with namespaces is what we call assembly definition. Yeah, it's what we call assembly definition, and this is specific to Unity. It's a Unity feature for C#. Generally speaking, when we refer to this in the normal software engineering practice, in the normal desktop or web development for C#, we use like C# project for this. But in Unity, because everything is inside the same project, the way how this is being done is assembly definition. But what does assembly definition mean, right? Before we know what assembly definition means, we need to know what is an assembly. So an assembly is basically just a fundamental deployment unit of in C#. So these are the code that you want to compile to a single .dll, which is a dynamic link library file, or a .exe file, an executable file. So all the code under the same assembly. All the code under the same assembly is going to be compiled into the same executable or library file. And by default, Unity provides us with this assembly-c#.dll, which is where all your code is going to be if you don't enforce any kind of assembly definition in your project. So what this does, what makes this bad is that all code must be recompiled when you make any kind of changes to other code. Because they're in the same assembly, I compile to the same file. This means that any changes in it might actually cause different parts of this same code base to be invalid. So the compiler always recompiles all your code when you don't use proper assembly segregations. And you'll also be able to directly refer to any other code in your code base. Even if you do namespacing, all you need to do is to add the using statement, which in one way or another could potentially promote bad design and complicate refactoring efforts in the future. Because all the code can refer to all other code. And in some cases, you probably want to work on cross-platform deployment and development. And scripts are, in all the scripts that you put inside of this main assembly is going to get compiled across all platforms. But some platforms have different ways to do stuff, which might or might not break your deployment on certain platforms, which is not desirable. So the way how Unity tries to fix this is using something called an assembly definition. So an assembly definition is a way for you to organize your code, like how you can do logical namespacing in C#. It's a way for you to modify your code such that certain parts of your code base gets compiled to different DLL files so that you have a segregation of so-called different code bases in the same code base. So the benefits of doing this is that you can recompile the scripts only if a change in your other code base actually affects it. So if there is no relationship between these two code bases, a change in A is not going to cause B to recompile, and vice versa. You can also specify which assembly you want to compile to which platform, which I'll show you later. So it solves the problem of cross-platform compatibility for certain code excerpts. It allows you to organize your scripts in a more modular manner. Now you will be able to create library packages for Unity with assembly definition. In fact, this is how most library maintainers for Unity does it. They create their own assembly definition for it. So basically, this is like how how you can try to visualize this. Originally, by default, all Unity scripts will get compiled into this assembly C#.dll, which contains all of your user script. Then, with assembly definition, you'll be able to move all of these scripts into their own small packages that you can then ship out properly. And then you also enforce some kind of relationship dependency between these packages. So now stuff.dll doesn't have all the scripts, but it refers to library, but it's completely separated from third party. So any changes in third party is not going to cause stuff to recompile, but changes in library is going to cause stuff to recompile. So it enforces a relationship like this. So the way how we can do this is, let's get back to here. Now that we have added all of our namespacing to our enemy script, let's add an assembly definition for our for this enemy folder. So assembly definition enforces directory rule, but not in a literal sense. It's not going to make it such that all of these classes inside of this directory must use the same namespacing as you named your assembly definition. But what it's going to make is that all this script inside of the same directory and all subfolders inside of the same directory that does not contain an assembly definition will be managed under the same assembly definition. Let me show you what it means. So as you right-click Create and you go to Scripting, you will find Assembly Definition. As you click on it, it will tell you to name it. Let's name this just gameplay.enemy. Usually it's good practice for you to name your assembly definitions to have the same name as your namespace, but only the base namespace. Then you'll be able to assign a root namespace property to this. What this does is that it makes all new scripts that you create under this directory to have this namespace attached to it already. So if I put gameplay.enemy inside here, and you always click on apply once you make any changes to an assembly definition. If I create a new model behavior script, let's just call this like enemy test.cs, right? And I open this up, you see that it already has the namespace gameplay.enemy attached to this. So then I don't need to change the namespacing. But it is also possible for me to add new namespacing to this. For example, I can change this to enemy.test, and this will still compile without any problems because assembly definitions and namespacing are still logical. And what it does is that it only enforces that all scripts under this same directory and all subdirectories of this assembly definition to be under the same assembly definition. So now what you're going to see is that now I have a lot of problems here. And these are all coming in from my script where I created for the behavior tree. It has using unity.behavior, but now it has red squiggly lines to it. This is because whenever you create an assembly definition, Unity by default makes it such that you will never be able to use any namespace that is not part of the system namespace or part of the Unity engine namespace. This is to ensure that you have the least number of dependency to this assembly definition as you create it. But in this case, my behavior tree scripts does depend on the Unity behavior package, and I will want to be able to use the namespace that this Unity behavior package is declared in. If not, how am I supposed to refer to the classes inside of this package, right? So the way how we refer to other packages inside of my assembly definition is here. You see there is this assembly definition references. If I click on plus, I'll be able to select one of these assembly definitions inside here, and it will allow me to use the namespaces that is declared under this assembly definition. So if I choose Unity behavior, click on apply. Now you can see as I go back to my detect player script, which is under my gameplay.enemy assembly definition, which uses the Unity behavior package. Now there's no more squiggly lines, and this compiles properly. Because I am now able to use the namespaces that's defined under the Unity.behavior assembly definition. So there's this use GUID thing, right, which just makes this much easier to solve merge conflicts, because if you untick this, now it's going to save all of these assembly definitions with plain text instead of GUID. Is there any downsides to doing that? I don't know actually. I think it improves performance by just a little bit, but honestly, unless you have like hundreds of assembly definitions, this shouldn't matter. So there's also all these kinds of different properties. You can check to allow unsafe code inside of your assembly definition, which allows you to write, well, literally unsafe code. In C# you can write unsafe code that uses raw pointers such as you can in C++. It's kind of anti-pattern in most development cases, but in performance critical situations you might need to use it. So this option is available. You can tick it if you need to. There's auto-reference, where it allows this assembly definition to be automatically referenced in predefined assemblies. So predefined assemblies in this case refers to system assembly and Unity engine assembly, which basically you won't really use. So other than that, I think the general options I don't need to explain much. You can try to experiment around it. So you can also define which platform this assembly definition is going to be compiled to. When you click on any platform, it's going to compile to all platforms. You can choose to exclude certain platforms from this compilation. For example, if my code, I know this package is not going to work in Android, then I can untick this. I can tick this, that is going to exclude the compilation of this assembly on Android platforms. You can also define certain constraints. So what these constraints do is that you can define that this assembly definition only gets compiled if this constraint is true. So some constraints is like Unity editor or certain versions of Unity. I think it's like something, okay, I don't really remember, but you can choose something like this, Unity editor, or like, I think it's shit, I don't remember anymore. Yeah, basically you can define these. If you are familiar with C or C++, you should know these as like pragma constraints. You can do #pragma, define a particular constant with this constraint. And if you put this constraint in, it's going to check if it is true or if it's available. And it will only compile if this is available. So let's not go too deep into this. There's also version defines, where you can click on add, and it's going to let you select one of the other assembly that one of the other package or assembly that this project has. So for example, I can choose like I want the input system, and it allows you to define a particular constraint if this version is or greater than a particular version. So I think you can play around with that, but usually you wouldn't use that unless you have a strong dependency for one particular package to be of greater or equals to a particular version in order for your in order for this assembly definition to work. Usually this would be useful if you're working on package development, but if you're only working on your own game development, usually you don't need to touch this. So this is assembly definition. Yeah. There's like, I don't know, there's like some errors, but I don't think it matters that much. So so now we can look at this, which is the access modifier table for C#. You see that there are references to same assembly and other assembly. So unlike Java, we don't work with packages for our access modifiers, we work with assemblies. So if it's within the same assembly definition, then we call it in the same assembly. Or if not, then it's the other assembly. So you can just take a look at this. Usually the most common that we use is public, protected, internal, and private. Internal and private. So yeah, you can just take a look. The other ones are usually less commonly used, but they might be useful in certain cases. You can find this table on the Microsoft documentation website as well. Okay, testing. Okay, so far are we okay? Yes. So testing is another thing in Unity that you can do. Actually, I don't think I'm gonna go very deep on this because I don't usually do testing on my end as well. But yeah, I think we can just take a look. So why test, right? Is for you to catch bugs early, for you to ensure functionality and stability. And in certain cases, changes to your code base might cause other places to bug out. Right? This is what I call regression or spaghetti. So you want to prevent these kinds of things from happening. So you test and you do automated test. So that on every single deployment of your game, when you build it, it will test first and see if there's any problems. If there's problems, it doesn't allow you to compile and so on and so forth. So there's this thing we call the Unity test framework, which allows you to automate your testing. And it uses this open source test framework for C# called NUnit. It's an integration of it inside Unity, done by Unity. So you're able to test scripts that can be based on edit mode and play mode, which now this framework is compatible with Unity 2019 and above. So you can just install this package. I don't remember if this is installed by default. It's been quite some time since I last used it. So let me just check my package manager. So test. Okay, I think it's installed by default, but you can update it because there's a new update apparently. So let me show you how it's done. So now, for example, now I want to be able to test my enemy code. Okay, I want to be able to test my enemy code. What I can do inside of my enemy folder is I create a new folder called test. Okay, let me just delete this. So, important thing to note is that if you want to create test for your code that is under an assembly definition, you need to create a test assembly for it. So how you can do this is how do I do this? Hang on, give me a moment. Where's the menu for that again? Oh, okay, test runner. So you go to Window, General, and the test runner is here. I swear it wasn't there. That's like, they moved it, I think. So you'll be able to bring up this test runner panel, which there's edit mode, play mode, and player. Player is for you to test on a complete build. Usually you wouldn't need to do that unless there is like specific pragma conditional compilation that you do that only makes sense in one platform and not in the play mode. But yeah, so for example, now I want to test for play mode, then I just click on create a new test assembly folder in active path, where it's now going to create this test folder. Let's just rename this to play mode test. So because it's already in a test folder. So as I open this up, you see that it already created this new assembly definition for me. So let me just put this in gameplay.enemy.test.play mode. And let me give this to the same root namespace. And you see, it already refers to the Unity Engine test runner and the Unity Editor test runner definition. And it has already included this define constraint, which is Unity include test. So let's click on apply. Okay, a scripted class as a what in the fuck? That's very interesting. Okay, so yeah, I think the behavior tree probably glitched out. Oh no, I think my Unity is crashing. Okay, I think my Unity crashed. Whatever. I just record again. Then I just combine the two. Okay, so now that I have my test assembly created. Sorry. Now I need some test script. So let's just go to scripting and create a new model behavior. But let's just call this like enemy test. Okay. Just give me a moment. So let's open this up. Let's reload this. We don't need this to be a model behavior. Okay, we don't need this to be a model behavior. Give me a moment. So I don't need this to be a model behavior. Now all of the methods that I define under this, we can make this a test method. So how we do this is we must put the Unity test attribute to this. And now I just need to create any kind of method under this. So usually a good idea for you to make runtime test is you use an IEnumerator class. You return an IEnumerator. Why? Because this becomes a coroutine, and we will then be able to work on time intervals and etc. when it comes to using coroutines. So when we define this enumerator, let's just use one of the better practices when it comes to testing, is that you want to do something like the object. For now, let's just put this as enemy state controller, and then we do an action, which is usually the method name for the class for that we want to test for in this class, transition to, and then it does a success. Okay, so what we do in here is that we're also going to now we just do the test that we want to do. So in this case, I'm just going to test if I will be able to transition from one state to another, and then this transition is recorded inside of my controller. Okay, so first of all, I am going to need a controller. Okay, I am going to need a controller. Which I have to set this up in some way or another. So I'll be able to do a Unity setup here that allows me to set my script, set the test environment up. So I'll need some kind of instantiation. So I don't know, can I do serialized field in here? I think I can. So let me create an enemy prefab here inside of my test, and then this will refer to my enemy state controller. Interesting. It's like enemy prefab dot get component enemy state controller, and assign this to my controller. So the reason why this is red is because I think I need to add the assembly definition here. Okay, so you do need to add the assembly definition if you do have an assembly definition. So I'm just going to say var enemy equals enemy prefab instantiate. Okay, let's put this here, and then now I should be able to refer that I want to transition. So I say controller dot transition to state new enemy idle. Okay, yield return null. So when I do yield return null, I skip one frame inside of the coroutine. And then now I can do an assertion. So I'll be able to assert the type to be the same as enemy idle. So now hang on. Okay, sorry, there's a mistake here. I can't do a serialized field. I am going to need to load the resource with the resources.load with the resources API, because this is not a mono behavior. I can't just do a serialized field. So this takes in a string path. Yeah, I flipped on recording. This takes in a string path, which I'll be able to attach it to a prefab. So I just realized I haven't created a prefab yet, so let's just create a prefabs folder and put my enemy in. So now I have the enemy prefab. So this string is going to be relative to this assets folder. So if you do prefab /enemy, is going to open prefabs and find this enemy prefab asset and then load it as a game object, and then I would be able to instantiate it with a mono behavior. So now let me move my player further away so that I'll be able to show you that it works. So now as I go into my general, my test runner, I can go into play mode and it tells me that there is this one play mode.dll that's already here. So I will be able to right click on it to press run. Okay. Or there should be a button that allows me to do so. Okay, you can click on run all here. So as it runs, it's going to compile your script and it's going to run the test as it does. And it tells me that the test has failed. And why has the test failed? The object you want to instantiate is null in my setup. What do you mean it's null? I thought I loaded it. Okay, let me assert that it's not null. Wait, that's weird. Man, I hate working with this. This one. Resources dot load. Load string path. Ah. Okay, this should be correct. It's relative to one folder above the assets path. Okay, now I run again. So you can see that as it runs, it actually starts the play mode, but it doesn't do anything. And could not load enemy prefab. Oh no. What? Eh? I'm stupid. I'm stupid actually. The resources API requires this to be under a folder called resources. Drag this in. Okay, now this should load properly. Okay, so it does load properly, but the enemy controller has not been assigned. This means that my enemy doesn't have a controller on it. It should. The variable M player of the enemy controller has not been assigned. You'll probably need to assign the M player variable of the enemy controller script in the inspector. So now I need to make my player a prefab and then attach this here. Okay, great. Let's run again. And set destination can only be called on an active agent that has been placed on the nav mesh. What do you mean it has not been placed on the nav mesh? That is concerning. Where is my enemy? Where is 000? Is that not on the nav mesh? Oh, this is not on the nav mesh. Okay, then I need to put it on the nav mesh. 1 maybe. 0, 1, 10. Okay, let's spawn it at 0, 1, 10. Okay. New vector 3, 0, 1, 10. And quaternion.identity. Let's run again. What do you mean it has not been placed on the nav mesh? That is very weird. Wait, that is very weird. Is it not on the nav mesh? Oh, I think I need to load this sample scene. Oh no. Build the next one. Syntax one. Okay. This is why I hate working with playbook tests. I should have tested this out before I do anything. Okay. Okay, good. So now I have this problem, which is the object of type enemy state controller has been destroyed, but you are still trying to access it. Why has this been destroyed? What the fuck? Do I need another U return now here? Let's run. That is weird. Pause to record. Okay, so I made some changes to the script. Now, what it does is that first of all, I remove the player and the enemy from the scene so that it doesn't cause any conflicts with any runtime instantiated objects. Then, I added these in. So I spawn the player during the scene setup. I spawn the enemy during the scene setup. And then here as a transition, I just check if the transition is correct. So now as I run this selected, what you're going to see is that here it passed, so it takes everything. And then it transitions to the and all of the debug statements, right, is going to show up here. So if you do debug.log warning, log error, it's all going to show up here. Okay. Yeah, so this is how you can use the test runner to help you automate your testing. And it is actually possible to use the test runner to mock things such as input. And you can also do UI tests with the test framework. I'm not going to go into how, but you can look up a lot of resources online to do that. So yeah, this might be useful when you're trying to build larger games that have tons of functionality, because automating all of the functionality tests is going to save a lot of time. Then you don't need to keep replaying and replaying to figure out if any functionality is incorrect. You can do unit tests, integration tests directly with the test framework, so all of these should be possible. In fact, in the example I showed just now, it's actually an integration test. It's not really a unit test because I test several different components through it. Okay. So, the difference between the edit mode and the play mode is that for edit mode, it runs in the editor loop. So it runs directly in the editor. It doesn't need to open up play mode for that. And you use it generally to test for non-gameplay code or library code. For play mode, you test for gameplay code, and it runs in the player loop. It's as simple as that. Then we work on something called debugging. I think this might be familiar to you if you've used any kind of IDE before. It allows you to set up breakpoints in your IDE, and then as you execute, once it reaches the breakpoint, it's going to stop the execution of the program so that you can inspect the variables and any kind of data in at this particular time step when this code has executed to the line that you set up the breakpoint to be. So if you use Visual Studio or JetBrains Riders or Visual Studio Code with the Unity extension, you'll be able to attach your IDE directly into Unity so that it works with the play mode execution. And it's really just as simple as pressing two buttons. And you can also attach this to a development build. So you can build it out and you can attach your debugger onto the build binary. Unity provides you with this functionality to do so. So you'll be able to test it across different platforms as well. You can test it for mobile builds. I think the only build you can't test for is like console, if I'm not wrong. You can't debug you can't attach the debugger to is like console. So this provides you with a lot of power because you'll be able to know like potentially what is going on with your code that is causing a particular bug. It's called a debugger for a reason, right? So let's take a look at how you can do this. So now specifically, I'm just going to put my enemy and my player back into the scene. And let's just give them some random positions. So let's put my enemy over here. And I'll put my player like over here. Okay. So now in my enemy code, okay, I'm just gonna go into the controller, in my state controller. So notice how I'm actually doing a debug log here to figure out if I'm actually transitioning a state. Sometimes you don't want to do this because there are certain transitions that you think might be buggy and you probably want to check for that. So what you can do is you go to here and you click on here on the left pane and it shows up a red dot. This is considered as you have added a breakpoint over here. So what it's going to do is that as you debug, once the code executes to this point, it's going to stop. And then you'll be able to inspect the variables for your program up until this point. And it's as simple as just clicking on attach to Unity, which is going to make your Visual Studio have this like red bar on below here. Now your debugger has successfully attached to your editor. And as you click on play here, what is going to happen is that as soon as the code execution reaches here, you'll be able to see what is going on. So it tells you that this is the enemy, the current state is idle, and then the enemy has these properties where you can open this up. And it tells you what is like the differences between, it tells you like all that it can do, all the values that is attached to, all the references that it has. So this gives you a lot of power to know what potentially had went wrong over your expectations, and it helps you to find your bug. So for example, you want to know if like what does the .exit does for your method. So you can click on this step over, which is going to go to the next execution. Now we're calling a method. When we do step over, we're going to ignore the method calls, and then we execute over the method call, so as if the method call has been completed. But we can also do step into, which is this button over here, right next to step over, which is going to get me in to this statement. Okay, and it's going to tell me what it does. Right. So this exit goes to countdown token source.cancel. Okay. And then if I want to step out, I just need to step out here. And then I'll be able to move forward. And then, okay, enter. So, as I enter, this tells me that I enter a moving state, position. Okay, I move to this destination. My destination is a random point, which is this. Then I can click into to see what my move to actually does. Okay, so this is a bridging method. I step in again. Oh, it does a navmesh agent set position. So once I'm done with all of this, if I don't feel like this particular session has given me a good insight, I can click on continue. So my game will continue to run until, again, transition to state has been reached. This line execution has reached again. Then I can check all the different variables again to figure out what might have gone wrong. And if I feel like, you know, I've already done enough debugging and I found where the bug is, all I need to do is to click on this red square which stops the debugging, and I can stop the game, stop the editor play mode, and I can change all I need to change because I found where the bug is. Ideally, you find where the bug is. So the general rule of thumb is that you should always set the breakpoint to one line before where you think the bug is, to validate your hypothesis that this is where the bug is, because then you can step through the lines that are potentially problematic one by one until you find the actual culprit, and then you fix the bug. So this is probably going to be a very... Hello?
You're shifting the tables.
Yeah, sure. So this is going to be a very long process, and you probably want to spend a lot of time working with debuggers in the future. Okay, so far we good. So this would be the last topic that I'll be covering, I think. Okay, so the last topic is profiling. So profiling is basically a term that is coined for you to check for your performance in any kind of program. So it's not just for games. You can use it for other kinds of software as well. So Unity provides us with a very easy interface called the Unity Profiler that allows you to check for every single frame, the execution time of every single method call. And it is also possible for you to attach the profiler to a development build. Because when you the editor actually induces some level of overhead. Obviously, the editor needs to update all the inspector things so that you can do runtime inspection, runtime instantiation, and stuff. So there's some level of overhead to actual gameplay performance when it comes to using the play mode in the editor. But you will be able to do profiling for a development build if required to, if you are required to do so. So to use the profiler, simply just go to Window, General. No, it's not in General. Where they put this? Analysis, okay. Analysis and Profiler. So this calls up this very big window that looks intimidating. But essentially what it does is it allows you to record certain... it allows you to see like how things are going. And you can check every single thing first. By default, all of this should be checked. There's the CPU usage, rendering, memory, audio, video, physics 2D, UI details, real-time global illumination, and virtual texturing, which is basically all the metrics that you need to figure out why your game is going slow or which particular phase in your game frame generation is getting slow. So just click on play mode, we just start playing. And you see that it starts generating all of this. Now once you get enough data, you can just click on pause. So what are these, right? This graph here shows you the CPU time that is this bar shows you the CPU time that is used by your game when it generates this one single frame update. So there is this red bars here which it tells you that your CPU exceeded your target frame time. This is the frames that are potentially problematic, where it probably does some kind of operation that is heavy. So what you can do, okay, is you double click and it's going to show you this particular frame time. And as you pull this up, it tells you that the CPU used 17.85 milliseconds to generate this one frame. Then I will be able to zoom this out to see what is causing all this lag. And it turns out that, so this is the editor loop, which is the overhead that your editor has. This is the player loop, which is the loop that is used to do all your model behavior update. So this is where your code, this is where the code that you have written is actually in. So you'll be able to zoom in here and see the time that it's taking for every single method to run. So on the horizontal axis, this is the time that it runs. So let's just zoom in even further to see where we have created problems. For example, graphics jobs. No, that is not a problem. Yeah, okay, there's actually not much problem here. So there's also other stuff that you can read up on. For example, the rendering pass. What is the rendering statistics? How many batches do I have? How many triangles do I have in my scene? how many vertices, and you can turn these on and off. Usually, if you only want to check for your script performance, you're going to turn everything off until you have scripts. And you see, because we don't have anything very heavy, we just have like a very flat line here. So what if I artificially induce some kind of heavy load onto my system? So every single time I transition to state, right, I'm just going to artificially add a for loop that runs 1 billion iterations that does nothing. So I'm just going to do like it's like int sum equals 0 long for I equals this number, I think. Okay. Is this 1 billion? Okay, we can add another 0, I think. Oh, this is outside the range of int. Okay, so yeah, this is 1 billion. So I'm just going to artificially induce some load onto my system, which is just going to be 1 billion iterations of plus equals operation. So now as I press play, I should notice some lag spike when I do transition. Okay, which now if I go to analysis and profiler, ooh, okay. See the lag spikes. The time suddenly spiked up for this one frame. So let's double click on this. The CPU took 1,318 milliseconds to generate this frame, which is 1.3 seconds. And all of this, which is 1.2 seconds, is inside the player loop, which is inside the update. Okay? Which is inside the update loop. So let us pull this up a bit. So I can show the hierarchy for the update loop. Okay. This is the timeline, which is what is taking so long. But it shows that it's inside of my behavior update. So now if I go to the hierarchy, I can see that my behavior update is taking up 95.4% of my CPU time. Okay, no shot, right? So this is in my enemy state controller.update. Okay. This means that my enemy state controller.update actually has some kind of very heavy operation to it. But all it does is execute, right? There's like nothing that it does. So the problem here is that, okay, inside of my hierarchy, this doesn't really show a lot of things for us, right? And that is because if I don't try to profile this deeply, it's only going to show me very little information. So now, what I'm going to do is to reload this with deep profile turned on, where it's going to show me all the details of what I need to know about what is going on with this script. Then I'm going to restart my play. Okay, we see the lag spikes now. Okay, this is the lag spike that we want. So it tells me that enemy state controller.update is causing a problem, which is the execute, which is the transition to state. That is taking up 97.2% of my time. So I can open up all of these method calls on my stack to figure out where my time has been eaten up. And obviously it's because I have a 1 billion loop here to emulate having very heavy operations. So this would be useful for you to figure out where in your script there such inefficiencies exist, and is potentially where you can look into optimizing your game so that it runs faster. Unless you work on like very large projects, this is very unlikely for you to encounter performance hiccups. As you can see, you need 1 billion iterations to let this run for more than 1 second. So it's very unlikely that you have workload as much as this. So yeah. So let us just remove that artificially induced load so that we can get back here. And then once you fix the problem, let's play this again, and you should see that even on deep profile now, I'm not going to see a huge lag spike. Okay, look at how this is now consistent because I fixed the problem that I created. Okay, any questions? No questions. Good. So there's actually one more thing I want to touch on, but I'm not going to demo it. This is a relatively new thing by Unity. It's called the Unity Project Auditor. If you open this up, why is it not opening? Okay, if you open this up, okay, you can see that this is only on version 1.0.1. It has been in development since Unity 2018 and only just released like a couple of weeks ago, I think. So what is this, right? This is actually a static analysis tool that will analyze your entire code base, try to find inefficiencies during compile time, look for bad practices that doesn't follow the coding style or the Unity recommended ways to do things, and tell you how you can fix them. Okay, it will link you to guides or just give you like IntelliSense suggestions for it. So this is very good if you're starting out with heavy Unity development, and I do recommend you to check it out if you don't know what the best practices in Unity are. It will give you a lot of insight about how you can improve your code. So you can just install this in the package manager, as far as I know. It's called the Project Auditor. Is it not available? It's the package. How do I install it? Okay, I need to add this into my install package by name. Okay, there it is. I don't know why you cannot find it. Oh, it could be that I probably have already installed it before. Oh, maybe not. I don't know. So once you install this, it's as simple as going to Window, Analysis, Project Auditor. This shows up, and you click on Start Analysis. It's going to read through all your code, and it's going to tell you what you've done wrong and how you can fix them. It takes a while, usually like a minute or two, if your code base is decently large. But it's gonna go through every single script that you have to find out what are some of the bad coding practices that you've done. Generally speaking, I do think static analysis tools to be very convenient when it comes to catching very trivial problems in your code base. So, okay, it tells me that I have 834 code issues. Okay, there's resources as folder dependency. So it's not a huge problem. Okay, it tells me what are the problems. So the resources folder is a common source of many problems in Unity projects. Okay, improper use of the resources folder can bloat the size of a project's build, lead to uncontrollable or excessive memory utilization. So what is the recommendation? Use asset bundles or addressables when possible. So it tells me what are the problems. and it tells me how I can fix it. Okay. Some of these you probably don't need to fix this. Some of these are not important. But, you know, it's always good to do a static analysis to check out what you can potentially improve in your coding style. Okay, so yeah, this is basically all that I'm covering today. Any problems, questions? No questions? No questions? Good. So this will be the final week for SWE in games. So starting next week, over the span of, I think I will try to plan it to be 3 weeks, but it might not have enough content to do so. We will be doing multiplayer workshop. We'll be doing multiplayer workshop in Unity. So I'm still in the process of planning out what should be taught. But I think maybe a very basic overcooked rip-off would work for multiplayer. So yeah, if you're interested, please join us next week. I think the live session would be better than the recording, because you'll be able to interact with me, and with multiplayer there's usually a lot of problems. So yeah, I guess I'll see you guys next week for the multiplayer workshop. And thank you for coming today.